Okay, section 8.4, double angle and sum and difference identities. So these are some more identities that we're adding. We're going to use these. We're still going to simplify to a single term using this information that we're given, as well as verifying if something is true by proving one side is equal to the other, like we've done in the last two sections. So let's get our identities here, and let's start with the sign. I'm going to make this one to be, and this is going to be, I'm just going to go like this. I just want it to be so I can separate them out. I want to be able to see that. So I have sign, and we're going to do the sum first. All right, so I'm going to use some color here to kind of coordinate what I'm doing. So we're going to say sign. We have the sum of x and a y here. This is what our identity is. This equals sine x, sine of x times cosine of y plus cosine of x times sine of y. Okay, and if you notice that I have an x and a y in each term, I also have a cosine and a sine in each of the terms as well. I also want you to notice that if this starts with a plus, then you have a plus between the terms here. So let's do the difference now. The difference is pretty much the same idea, except we're subtracting. So it's the sine of x minus y equals the sine of x times the cosine of y minus, though, the cosine of x times the sine of y. Now you notice that each term again has the sine and cosine, and then what's separating these two is if this is a subtraction, this is subtraction. Okay, let's try cosine. So I'm just going to do the sum first. So the cosine of x plus y, I'll do the difference like I did up there, equals to cosine x times cosine of y. Okay, and if I start with a plus here, this is going to be a minus. So pay close attention to that one. And then we're going to subtract sine x times sine of y. So I get these are our difference identities here. And then the next one I'll do is the subtraction. All right, let's see how we use these. Now, you want to look at this, this expression here, and I have a sine of 40 degrees times a cosine of 20 degrees. cosine of 40 degrees, sine of 20 degrees. So I want to think about, okay, if I see that, sine, cosine, cosine, sine, and there's a plus here, that means I am using this one right here. Okay, I've already got the right side right here. I just have to figure out how I connect it to the left side. So what you want to do is you want to think about this formula. And in this formula right here, I have the x. So the x for us is here at 40 degrees. And the y is the cosine. And again, I'm just getting it straight, and the sine over here. I'm getting it straight from this identity up here, and I'm just substituting what x and y is, okay? And just based on what I see, comparison. I'm going to write underneath too so you can see what I'm talking about. Make sure you understand where I got that from. So this would be sine of x times cosine of y plus cosine of x times sine of y. Now, how is that going to help me? Well, I know that if this equals to my sine, let me get it over here. I'm in a room over there. Okay, this equals sine x plus y. So these are two terms, but then I can really make it one if I just give it this side. So what do? Well, in place of x, I'm going to put 40 degrees. In place of y, I'm going to put the 20 degrees. And then now what does that equal to? That's just sine of 60 degrees. Well, you know sine of 60 degrees. Sine of 60 degrees is the square root of 3 over 2. I'm getting that straight off my unit circle. Sorry, I wrote that wrong. And so make sure that you are going back and reviewing that. Maybe have your chart out when you need it. So again, this is square root of 3 over 2. And that's my final answer. Remember, it's a term, a constant, it's a number like that can be an answer. So now let's go on to the next one. Okay, for number 2, we have a cosine here and a cosine plus a sine and times a sine. So we don't want to use sine at all. We're going to use one of these two. I'm going to pay attention to what we have. Since this is a plus when it's cosine, that's a plus, so therefore this has to be a minus. So what I have right here is, so this will be cosine, let's just do x minus y, because this is a plus, okay? So now that we have that information, let's see what x is and let's see what y is. So this is your x, based on my problem up here, and this is your y. So now what I do is I'm going to do what I did over here in the same one. I already have this information. I want to do this. And the reason I want to do this, because remember, this is two terms. I need a single term. In order to do that, I can't have this, so I'm going to try to go back to what we start with originally. So if I know that x is 35 and y is 20, then I can put in here cosine x is 35 minus 20. So let's clean this up. Cosine 35 minus 20 is cosine of 15 degrees. Now, we do not know what this is, okay? This is not a common angle we know. So we're just going to leave it as it is. And this is what your answer. We're not going to use a calculator because we don't really need it. We're not trying to get the exact answer like that, like we can on the other ones. But we're going to leave that. So based on what I just said, let's talk about what are the common angles. So remember our common angles that we know. Common angles we know will be your 30 degrees, 45 degrees, 60 degrees. But don't forget the ones that we use, 90, 180, 270, and 360 are 0 degrees. And those are what are on the quadrantal angles, which are on the unit circle lying on the radius. So make sure you understand what I mean is that here is my unit circle. Here's the X and Y axis. And your radius is 1 here. So remember, all these values are the quadrantal angles that land on top of this. And they all have certain values that are either 0, 1. So here this one will be 1, 0. Because you go over 1, but you don't go up and down. Here this is 0, 1, 0, excuse me, negative 1, 0. And this will be 0, negative 1. So kind of remember those. Use your sheets for now, but you should have those memorized, okay? Kind of bring them back like we said before. So we're going to use this information to help us find and verify that the statements are true. Okay, so let's look at number 1. Remember, we're verifying. That means we want this to equal this or the other way around. You pick a side. Your answer is all the work. Okay, so this one is telling us that we can verify that sine pi minus over 4 minus pi over 6 can equal the square root of 6 minus square root of 2 all over 4. Okay, so this one the left I'm not going to use because, excuse me, the right I'm not going to use because I don't know what to do with that. I mean, how do I make it look like what's over on the left? So it'd be easier to work with on the left because we have an identity. Okay, so we have a sine, and this is an x minus a y, so we just know we have this sine x minus y. And if I have a sine there, then the one that I want to use up here will be the one that's a minus, and so further there's a minus there. And it's sine x, cosine y, cosine x, sine y. So I'm going to rewrite that down here real quick so that we can make sure we can use that. So if I write it, let me erase this stuff out of the way. I'm going to write it above this one thing here. Where's mine? Okay, so we're just going to write this as, it's going to be sine x cosine y, this is a different color so we can see it, minus, because this is a minus, cosine x sine y. So just pay attention to each of these when they're being used and so forth, okay? So now I'm going to have to rewrite this using this information up here, okay? We know that this is x, and then this one's y, based on what the position is. So since we know that this is x and this is y, we can replace what's in this up here. So sine of pi over 6, so I'm going to have sine x is pi over 4 times cosine of y, which is pi over 6, minus cosine of x, which is pi over 4 times sine of y, which is pi over 6. Again, keep working until we get to this. So all the cosines and sines must be gone because there's nothing in here. So we'll just use our unit circle and determine what the values are of these. So the sine of pi over 4 is the square root of 2 over 2. That's this part right here. Times this one, cosine of pi over 6 is the square root of 3 over 2. Okay. Minus what we have on the other side there. So we have minus. All right. Now the cosine of pi over 4 is also the square root of 2 over 2 times sine pi over 6, which is going to have to be 1/2. Now multiply it out and see if you can get what's on the right. Okay. So when I multiply these two together, I get the square root of 6 over 4 minus this. When I multiply together, I get square root of 2 over 4. Now, I need this, which they have them all over the same denominator. Well, that's what I can do here. I have two denominators. I have 4. So combine them by just putting the numerators together. And that does equal what we have over here. So therefore, it verifies. Remember that all of this is your answer. All of this. Everything you do is the answer. Remember, at the end, you must show that these two right here are exactly the same at the very end, but you don't box it in because that's not the answer. They should look the same, and then you know you're done. Okay, so the next one we're going to do is number 2. Okay, number 2. We have the cosine of 15 degrees. We want to see and verify that it equals to this over here. Okay, again, I don't know what to do with the right to get to the left, but I can do the left. Now, what you want to do with the left, obviously we're talking about these sum and difference identities, so we're going to use something like this. So we have a cosine, so we know we're going to want to use one of these two cosine equations up here. Okay, now what we want to do is we want to use the angles we know. We don't know cosine of 15 degrees, but using this information, that the ones we do know, I'm going to say that cosine of 15 degrees is the same as cosine of 45 minus 30. And that does give me 15. So now that I do that, I now have an x and a y. And so I'm using cosine 45 minus 30. I'm going to use this one right here. Okay, so remember it's cosine, cosine, sine, sine. So we are going to fill in that in. So looking at what you have, I know that I have cosine x 45 minus 30. So that means I have to have, this has to equal cosine of x, which is 45, times cosine of y, but y is 30 degrees, plus the sine of 45 times the cosine of 30. Okay, so now we're going to work with this here to see if this, to get what's up true there. Okay, so now let's do our unit circle, and we're going to want to know, I'm going to move this down this way. What's the cosine of 45? Well, we just did that earlier. It's square root of 2 over 2. Times, what's the cosine of 30? Cosine of 30 is the square root of 3 over 2. Plus, the sine of 45 is the square root of 2 over 2 times cosine of 30, which is 1/2. Guess I should have done this blue. Doesn't really matter. Okay, so now let's look at doing the math and seeing if we can combine like we did just this last problem. This was the square root of 3 over 2. Trying to make the same color. Okay, so now I have the square root of 6 over here over 4 plus the square root of 2 over 4. Just multiplying fractions. Add those together. To put it under one denominator, we get the square root of 6 plus the square root of 2. Well, that's what we wanted to prove. So we know that equals the square root of 6. I'm just going to put different colors so I have them separate over 4. And this checks. Again, all of this right here is your work. And all of this work is your answer. So make sure that you are showing all of that. All right, number 3. We have to verify this. This time though, notice that we don't have just a number over there, okay, or constant. Remember, these up here are constants because they're just numbers. This is a trig function, so we're not going to give that kind of answer, but that's okay. So let's see how we can figure out what we need to do. We're going to use the same idea. I have an identity when I have the cosine and I'm subtracting two things, okay? So if I have a cosine and I'm subtracting an x and y, I know it's going to be cosine x, cosine y. And if this is a minus, over here has to be a plus, sine x times sine y. So let's just put in now what we have. We know, though, that this x is this, and we know y has to be this, based on this. So we're going to put our x and y's in here down here, and we're going to see what we can do to get to the other side. All right, so we know the first one will be the cosine of x is just x. The cosine of y, well, y is 3 pi over 2 plus the sine of x, which is just x, and the cosine, the sine, you want to say that's a sine of y, which is 3 pi over 2. Okay, so hopefully with what we have this information, we should get rid of these cosines because we have no cosine in this answer. Okay, so let's see. Cosine of x is just cosine of x. You can't do anything with that one, so I'm just going to leave this here. Now, what's the cosine of 3 pi over 2? Well, let's go back to my little circle here. 3 pi over 2 is here, which is 270, and cosine is 0. So I know this is going to be times 0. Plus, here I have sine x. Sine x is just sine x. And now I have times, well, the sine of 3 pi over 2 is negative 1. Well, it looks like I have my negative hopping up here. So that's helpful because we need to make sure we have that. So now cosine times 0 is just 0. You don't even have to write that, but this becomes negative sine x. I'm just move the negative in front. Negative 1 times sine x is negative sine x. And that does equal the other side, which is negative sine x. So this is your answer. This is all your work. Okay, make sure you're showing all that work. Whatever you do has to match what you're doing, and you just can't skip steps, unfortunately, unless it's just like, maybe putting that 0 there when I didn't really need it, but can't skip the important steps. How's that? Okay, that's number 4. Number 4 has a sign, and we have a plus. So that means I know that I have to have sine x plus y has to equal sine of x cosine y plus, because this is a plus, it's the same thing, cosine x times your sine of y. Okay, so let me erase this little mark here. Let's look at what we have. We can still have to figure out what x and y is. So when we look at this x and y, they're in that order. So that means this is your x. And I'm going to make this one your y because the spot is in. I like this problem because we get stuck in a rut that x is x and where it is, that means that's what it's supposed to be. Well, according to this, it's not. X is now y. If it confuses you to look at it like that, then you can label 2 pi maybe over here equals x. And then you can say that x equals y so that when you stick them in here, you'll know where they go. Might want to make this that color and this one this color. Whatever helps you to coordinate it, whatever you need to do. It's up to you. So now I'm going to write it out. So I have sine of x, which is 2 pi, times cosine of y. Well, cosine y should be cosine of x. Okay, and one thing about looking at what you have to find, you're looking for this over here. Notice there's only an x in there. There's no y's. So you have to make sure that when you get done with that you don't have that. So it kind of helps to know that that's gone. Might help you remember to be careful. So the next one we'll do plus the cosine of x. Well, x for us is 2 pi. And then the sine of y. Well, y is actually x. Okay, which is good because we need this x here. And I see it right here. All right, so let's see what we do. So now we want to find the values. Well, sine of 2 pi, that's at 0. So sine of 2 pi, this is 0, times my cosine of x. Well, that just cancels, which is good because I don't need a cosine. I don't have any cosine in my answer that I have over there. Plus the cosine of 2 pi, Well, 2 pi, cosine 2 pi is just 1 times just sine x. So now I have a 0 plus sine x. So over here, I just have sine x. And so I need to put this down here showing, yes, it does equal what I started with. And it verifies it. Again, I do have to see this last step because it's showing to me that you know exactly what is what. Also, it helps you to conclude what your problem is.